the fifth mean?
4 times 4.
Okay, good. So we got 4 times 4 times 4 times 4 times 4, right? Okay. What does 4 to the third mean?
4 times 4 times 4. 4 is 3 times.
Okay. Now, can I it might make sense to do this for this particular case. Can I do times 1 times 1? Is that still 4 to the third on the bottom?
Yeah.
Okay, so let's pair these up. Let's rewrite these. I guess we don't have to rewrite them, but let's regroup these. We got that one. We got that fraction. We got, I'll just kind of alternate back and forth between green and blue. Okay. So what is this first blue one? What's 4? If I look at that as just a fraction, what's 4 over 4? 1. Okay. What's the second one? 1. What's the third one? 1. Now the next one's 4 over 1 is 4. 4 over 1 again is 4. So how many 4s are you really multiplying together here when I do 4 to the fifth over 4 to the third?
2.
You're left with only those 2. Everything else canceled out, right? So I'm left with 4 squared instead of 4 to the fifth over 4 to the third, right?
Well, can't you just subtract those 2?
Absolutely. So that's the relationship that I want you guys to see here. No matter how many things I put up here, if I have 54s and 35 4s on the bottom, when I do this process, 35 of those are going to, so 50 and 35. If I go through this process, 35 of the 4s on top and bottom are going to pair up and give me 1. Does that make sense?
1.
Okay. Just like here, 3 of the 4s on top and bottom paired up and gave me 1 times 1 times 1, right? Okay. So Ollie's saying that all we've got to do is take those 2 numbers and subtract them. So I want to write this real quick. 4 to the fifth over 4 to the third is equal to 4 to the 5 minus 3. So that's my exponent now. There's a difference in those. And that is going to give me 4 squared. Okay? When we look at dividing like bases, we subtract the exponents. Think about this. When we're multiplying like bases, what do we do with the exponents? When we're multiplying like bases, we add them. Because multiplication is repetitive addition. Okay? When I'm doing division, I subtract the exponents because division is repetitive subtraction. Okay? So when we divide, we need to subtract. Now, subtraction's order matters, right? Is 5 minus 3. Is 5 minus 3 the same thing as 3 minus 5? No. One's positive 2, the other one's negative 2, right? Addition didn't matter, right? 3 plus 5 is the same as 5 plus 3. So that doesn't matter. But when it's division, and then that turns into us subtracting the exponents, order matters. So when you do these, you need to subtract the numerator minus the denominator. It's always top minus bottom when we're doing these. Is that okay? All right. The general rule here says if I've got a to the m power divided by a to the n power, then that is going to equate to a to the m minus n. Okay? So that's the idea. In the last example, 4 was our a, 5 was m, m3 would have been n, and that's how we get 4 to the 5 minus 3, or 4 squared. Is it okay? All right. Now, when we do these properties, if we go back through 7.1, 7.2, 7.3, 7.4, when they're standing alone by themselves, like this question here, or any of these first examples, when they're standing by themselves, you're only doing one property at a time, they're not terrible in isolation. It's either subtracting, adding, or multiplying, right? Exponents. But when we start merging 2 or 3 of these properties and interplaying them all together at once, that's when people start getting confused and frustrated with this stuff. So just try to keep straight your rules the best you can, okay? So if I forget a rule, guys, what I always do is I go back to what I know exponents mean. If I forget the rule that I got to subtract, I go back to this. 2 to the 6th means this, right? 2 to the 4th means this, right? Now I got to know that those cancel, and I'm left with what? 2 squared, which ends up being 4. Okay? Could I have gotten the same thing by taking 2 raised to the 6 minus 4? And gotten 2 squared that way. But if I ever forget one of my exponent rules, I always expand things and try to think, okay, how many x's do I have? How many y's do I have? How many a's do I have? How many b's do I have? That kind of thing per what the exponents are saying, and try to develop my rules from that. Okay? So this next one, I'm going to write x to the
X to the
-3. So x, I'm going to go 4 minus 7, and that gives me x to the -3. But we don't like negative exponents, so what do we do with that?
You put on fraction, so it'll be 1 over x to the 3rd.
Good. Okay? So that's where when you do one law of exponents, a second one might generate. A second one might come into play, and you got to remember then, back to the section that stuff came from, what do we do with that stuff? Okay? What's the next one going to be? X to the 5th. Is that okay? Can we do those individual simple examples?
Yeah.
Lindsay?
I don't see like bases or like different bases anywhere, so like what would you do for that?
Okay, so the next ones, like right here. So we got m's and n's. Is that what you're kind of talking about?
Like let's say it's like for the 2 to the 6 to the 4th, it's like 2 to the 6 and 6 to the 4th.
Okay, so that's a good question. So so Lindsay's question is, what if we have something like 2 to the 6th over, I'm just gonna go 3 to the 4th. Something like that. That's what you're asking, right?
Yeah.
Can I, and let's just kind of, and this is the idea. Remember, I'm not sure about what I can do here. So is that 2 to the 6th?
Yeah.
Is this 3 to the 4th?
Yeah.
If I group those, does that turn into a 1 or anything real nice?
No.
No. Okay? So what happens is when we don't have like bases, we just leave it that way. We just leave it as 2 to 6 divided by 3 to the 4th.
So that would be the answer.
That'd be my answer. Okay?
Like
It's like saying that if I have like if I have x to the 6th.
9.
So even if you just like divide it out like 2 divided by 6.
Yeah, you could. So 2 to the 6th power, whatever that is, 32. So that would be 2 to the 5th is 32. So that'd be 64. So if you had 64 divided by, that's going to be 81. So 64 divided by 81, and you can see, do they have a like factor, all that kind of stuff. But if they're variable things, like a,
Like if it has like 2x to 6 and then like 6x to something, could you divide like the 2 and 6 equals 3?
yes. So let's say I got something like that.
Yeah.
So the 2 and the 6 will reduce to 1 over 3, right? But the x's and y's, they're not like terms, right? So that is kind of like what we got here. So here my x would have been 2 and my y would have been 3, right? And we saw there that those were not able to be canceled. So the x to the 6th over y to the 7th just stays x to the 6th over y to the 7th. That makes sense? So we only do this work, guys, if we can mesh or merge like bases. Okay? So when I look at this one, and sometimes, guys, the way I've structured these is just the way I was typing them. They're kind of in order, right? M and then N, A and then B, and then over here it's X, Y, and Z. And the order is the same on top and the bottom, right? Yeah. It doesn't have to be that way. And there could be, different variables up top that don't exist in the bottom or vice versa. Okay, so we're just going to go through and say, okay, I got M squared up top, right? I'm going to go through and see if there are any other M's. And there are. There's an M on the bottom, right? Okay, so what do I do with those M's? Subtract them. So what's that going to give me? M to the -3rd. Okay. Now I've got n's as well. So how many n's will I have? N to the 1st. Now do we prefer that format?
No.
No. So how am I going to write this?
So it'll be 1 over m to the 3rd, n to the 1st.
Okay, so m to the 3rd goes in the bottom. Where does n to the 1st go? It stays up top.
Oh,
Yep.
Oh.
Now, here's something I want you guys to make sure you understand, because some of us are, I think, on that quiz, we're making a kind of incorrect judgment. In, written that way, means the exact same thing as this. 1 n to the first power, right? Okay. Now, that coefficient is understood. That exponent is understood. Okay? Because the idea is when I look at that and I ask, well, how many n's am I multiplying by itself? It's just 1, right? But if I look at this, now how many n's am I multiplying by itself? It's 2. Okay? So this symbol itself, when no exponent is written there, it's an understood 1. I think a lot of people were thinking that. Okay? Especially on number 2. That is not true, right? What is n to the 0?
0. Well, undefined. Oh, wait.
1.
It's 1. Anything raised to the first power is, or 0 is the first is 1. So just make sure we understand that. Okay. This is n to the first there. What about the next one? I'm going to have a to the what?
A to the negative second. Oh wait, no. A to the second.
Well, I'm going to subtract these, right? So it's always top minus bottom. So negative 3 minus 5 gives me negative 8. Okay. And then I'm going to subtract the b. So when I subtract the b's, what am I going to do with the 7 and the 2? What's that going to turn into?
5.
B to the 5th. So how am I going to rewrite that?
Take 8.
So it'd be B to 6 over 8 to 8.
Good. Okay. I showed the last class this, and I think it's important for us to see this. And we'll spend more time on this when we get closer to the end of the course tests next month. But your question. So let's say we're on the end of course exam, which happens at the end of next month, end of April. They're going to say from. You don't have to write this down, but from the following. Indicate which expressions are equal to let's just write a to the negative 3rd, b to the 7th over a to the 5th, b to the 2nd. Okay, and then what they're going to do is they will have like a series. It's usually 6 squares where they've got expressions in those 6 squares. Okay, and you have to click on. There might be 1 that's true. There might be 2. There might be 3. There might be all 6 of them.
For 6 squares expressions in that. Check it out.
What are you watching?
I think that was Siri in my pocket.
Oh, she's
Yep.
stalking you. I knew it.
Hey Siri.
She doesn't. She never listens to me right. Okay. So one of your options would be, like, for instance, is a to the negative 8, b to the 5th equivalent to that? Is maybe b to the 5th over a to the 8 equivalent? And then one will see, let's say, a to the 8th over b to the negative 5th. We'll see. So it'll give us a total of 6 of these. And we're going to see which ones are equivalent. Instead of, and then this is just my suggestion to you, instead of, trying to, if you know your properties real well, this might not be a hard question to decide which ones of the 6 are equivalent to this. But this is what I would do. I would take a to the negative 3rd, b to the 7th, and we'll divide that by a to the 5th, b squared. Is that okay with everybody? I'm going to type that into Desmos. That's the original problem, right? Just double check this real quick. I got that written right?
Yeah.
Okay. So now let's see if that is equivalent to these other things. So I'm going to type in a
Bro, it do be feeling good in here, though.
to the negative 8th, b to the 5th, and I'm going to come down here, I'm going to type in b to the 5th divided by a to the 8th, and in this one I'm going to type in a to the 8th Does everybody kind of get what I'm doing here?
No.
Okay, so I type in all of these options that they gave me, okay? Now, obviously, Desmos has a problem with these because they don't know what A and B are, right? So I'm gonna come down here and I'm gonna write A equals, give me a number.
4.
4, and what do you want B to be?
7.
B is 7. The only thing that I would be cautious of is not making those the same and not making them 1. Does that make sense? Because with exponents, letting my base be 1, what's 1 squared? 1. What's 1 to the 15th? 1. So everything if it was 1, all I'm going to get back is 1s for my answers, right? And I'm going to get some arguments that are not necessarily true all the time. But now I'm going to look at these and we'll say, okay, if this was the original one, it gives back with those values of A and B, it gave me back that number right there, right? This gives me the same values of A and B. Does it give back the same result? That makes sense? Are those two numbers, those two decimals the same? So what's that tell me about that compared to that? They're the same. So I'd go find that box and I would check mark that box. What about B to the 5th over B to the 8th? Is that number right there the same as that number? Yeah. So what's that tell me about that compared to that? They're the same. If I get down to this last one, that number, different than that number, right? So A to the 8th over B to the negative 5th is not equivalent to what we started with. And that, I think, is a quick way to use our technology to help get those results and to maybe a little bit, I don't want to say bypass, but kind of go around a little bit our laws in a direct way. Does that make sense? Or going around having to use our laws in a direct way. The one thing, so we know with those B and A values that one was not the same as the other ones, right? This is why I want you to stay away from using 1 though. If I use 1, it would show no matter what I put in there would always be the same, right? Does that make sense? Because what's A to the 8th? 1. What's B to the negative 5th? Or sorry, what's 1 to the negative 5th? 1, right? So I'm always have 1 divided by 1, 1 divided by 1. This would be 1 times 1. This would be 1 times 1 times 1 divided by like 1 times 1 times 1, right? This doesn't make a whole lot of sense to use 1. Is everybody on the same page with that?
Yeah.
Okay. When we get towards the end of March, beginning of April, my plan is to start attacking some of the work that we'll be doing then, and then some of the old stuff that we've already worked on, bringing back Desmos, and all of us using Desmos to help us justify answers, find answers, that kind of thing. Does that make sense? I think you can use that technology in a meaningful way to get a lot of your answers from that test. Here I've got x's, right? Those like bases. What do you do with those exponents? Subtract them. What are you going to get?
0.
X to the 0. What's x to the 0?
No. 1.
It's 1, right? Okay. So, and remember, it's because when we divide things, we're going to subtract, right? But what's x divided by x? 1. If I've got that, basically what I've got in that box right there is saying I've got that happening 4 times in a row, right? 1 gives me 1 times 1 times 1 times 1, still just 1, right? Okay, so that's actually the reason why, you remember back in 7.1 I said we're going to raise something to the 0 power and we're going to talk about it being 1, right? And the argument was, well, we don't know enough math yet to really know why something raised to the 0 is 1, but now we do. If I take, let's just say 2 to the 3rd divided by 2 to the 3rd, that's 2 times 2 times 2, right? Over 2 times 2 times 2. That's 1, right? Okay. Well, algebraically, that says we're going to take 2 to the 3rd minus 3, which is 2 to the 0. You see then that 2 to the 0 is equivalent to 1, right? So this process of dividing like bases and then subtracting the exponents is essentially the proof of why something raised to the 0 power is indeed 1. So that's a good question. Do I need the 1 to show up? If I'm multiplying all these things together, do I need to multiply by 1? No, because it's just going to give me everything else, right? So I don't need to put a 1 there, or maybe a 1 out front or a 1 there. I could, they're not wrong, but usually we don't.
I looked at like 751 and like if you put it in, no mark it.
What the?
Math Excel marks it wrong.
No, like, yeah. If you put that in.
Did it give you, was that your final check or did you have an opportunity to fix it? Okay. On a test or a quiz, if it does that and you put, let's answer this question. Let's finish this question and then I'll go back and show you alternate formats and we'll talk about how that shows up on a test or quiz.
One X or just one? Just one?
Just one. Just one. Because all the X's end up canceling each other out. Okay? What have we got right here? What if I look at these Y's? Okay, so I'm going to have -1 minus -5, right? And what's a minus and negative?
It's a positive.
It's a positive. It means addition, right? So we get -1 plus 5. What's -1 plus 5? 4.
That's what I said.
Okay? So I'm going to have y to the 4th. Okay? Is that okay with everybody? And now if I look at these, say again?
8 minus 1.
8 minus 1 is 7, right? Okay. So I'm going to get y to the 4th, z to the 7th. Now, if you put a 1 out there because of this x to the 0, are you wrong or are you right?
Wrong.
You're right. That's fine. Okay. Lindsay's saying that Math Excel gave her an issue by doing that, putting that 1 there. If that happens and you know you're right, just let me know. I'll go in and fix it. Okay, I'll go give you points for it. But you have to let me know individually that was doing that to you. One thing to know is, like, when we did this, okay, when we did this initially, when we start with a fraction like this and we subtract exponents, you initially are always going to get something that is not a fraction. That phrase that I circled is not written as a traditional fraction, right? Okay.
It is.
When we put it over 1, then that's when we can start moving those negative exponents. Is that all right? Okay. One of the issues I get with people is they say, well, I know I'm going to do this looking at the y's. I know I'm going to -1 minus -4, but where then does that 4 go? It's always going to go in the numerator if you do this rule. Does that make sense? Now, an alternative way, and maybe this kind of validates that. If I had y, let's just go y to the -1 over y to the -5th. Could I rewrite that? Could I take this one and put it down here? Could I take this one and put it up there? And that y to the 5th means y times y times y times y times y, right? And the y to the 1st just means y, right? Do those two cancel? And I'm left with y to the 4th. And where does it belong? In the numerator, right? Okay. Is that where we're seeing it show up here? That's in the numerator, isn't it? Okay. So what I want you guys to know is that when you do the subtraction, it's always numerator minus denominator, and your result always goes in the numerator. It might be positive or negative, and if it is negative, you then need to address that. But initially, it always goes in the numerator. That difference always goes in the numerator. Is that okay? Something to keep in mind. When we talk about density, okay, why?
It's just stupid.
What is it?
I don't know. The depths of something.
The depth.
The middle of it.
Huh?
What are you talking about?
I know what I'm thinking in my head, but
I don't think that's
I don't
density,
know how to
though.
explain it.
Ah.
Heaviest something.
Okay, so density is mass
That's what it is.
divided by volume for like an object, right? Okay. Usually we're talking about like how, like we're talking about density, I'm maybe talking about like a cork floating in water, right? It floats because the cork is less dense than water. Okay.
There's air in it.
If I take a rock is more dense than water, so it's going to sink in water, right? Okay. We can do the same thing with like liquids and liquids, so like oil and water don't mix, right? Okay. But here's what we're talking about when we talk about population density. And the idea usually with population density is we're talking about square miles. Okay. So a square mile is 1 mile by 1 mile. Does that make sense?
Yeah.
Okay. If I've got one person in there, my population density is 1 person per every 1 square mile. Does that make sense?
Yeah.
If I do this, put 2 people in there, my population density is now 2 people for every 1 square mile, right? Put 3 in there, I've got 3 people for every 1 square mile. That's what population density is. It's people per area. Okay?
Why do they call it a square mile?
Is this a square?
Because it's, yeah, because,
I know, I was invested.
all right.
Oh, I got it wrong.
Oh wait.
The idea of density is how much of something, okay, whether it be a mass, an amount, a quantity of people, quantity of cells, or whatever, a population, divided by what you're going to put that population into. Okay, an area or a volume or whatever. Okay, so if you don't know that, which that's something that we talk about in science, but it's also something we talk about briefly in math. But on the end of course exam, let's say I don't know it, or it's a topic that they don't necessarily think you should maybe have 100% mastery of. They a lot of times will actually tell you, hey, we're going to talk about density in this problem, and this is what density is. Okay? And if I know how to read mathematical phrases, population density describes the number of people. What's the word per mean?
Per person.
Like each.
Mathematically, it means
It means divide.
it means divide.
Woo.
Okay? So when it says people per area, right? Look at the numbers down here. Is one of those numbers labeled people?
Yes. Yes.
1.21 times 10 to the 7th, right? Is there one of those numbers labeled like in terms of an area? A square unit, right? Square mile. So 4.81 times 10 to the 5th, correct? Okay. So now this is all multiplication. What can I do with those two numbers?
I mean multiply them. I mean divide them.
I divide them. Okay, so we can actually do that division. So go 1.21 divided by 4.81 gives me, I'm just going to write it as 0.2516. Okay, it gives me a much longer decimal than that. We'll just round it here. Okay, are these like bases?
Yes.
What do you do with their exponents with like bases?
Subtract.
Subtract them. So it's going to be times 10 to the second power. Now, is this number right here in the preferred format of scientific notation?
Nope.
No.
No, so
So it goes 2.5.
2.516. So I moved it 1 to the right.
Subtract 1.
So I'm going to move that number down 1, subtract 1. And it gives me times 10 to the first. Okay? Now, usually writing things as times 10 to the first is kind of trivial or silly. It just means move my decimal 1 spot to the right, correct? So when I say 2.516 times 10 to the first people per square mile, that really means 25.16 people for every 1 mile. Does that make sense? So when I go back to my picture, I would have 25 dots, 25.16 dots in that square. That's the idea of population density. Does that make sense? Lindsay?
So if you move decimal to the right, you got 1, and if you move to the left, you got 1.
Yes. Yep. Yep.
The one on the board. That's definitely not.
All right. So this here should kind of reiterate a little bit of what we did last week, but also kind of working still on what we're doing now. Okay. Remember what raising a quotient to a power meant. Okay. This means I'm having 2 over 3 times 2 over 3 times 2 over 3, right? That's what this means. Okay, you have 2/3 being multiplied by itself 3 times, right? Now, how many 2's would you really have on top?
6. No, 3.
You have 3 2's on top. How many 3's do I have on the bottom?
3.
3.
Say that.
Okay. So do you see, hopefully here, the pattern? This was 2 to the first over 3 to the first, right? Do you see that the pattern is just to take that number out front, or sorry, that number as the exponent, and multiply it by that exponent, and that exponent, and it generates that. We talked briefly about that on Friday. Okay? So let's kind of jump down here and do some of these examples. Let's go to, yeah, this one, it's kind of an ugly number.
Definitely an ugly number.
That's a 9. Why is it
Okay.
I hate the number 9.
Well, what's 9? So what's the exponent for this 9 right now? 1. So what am I going to do with that 1?
Multiply by 3.
Multiply by 3. So I get 9 to the third. That's an ugly number. That's what I was meaning.
Yeah, I hate the number 9.
Okay, so now 2, or t squared, is going to turn into what?
T to the
T to the
6.
fifth.
Good. T to the 6.
T?
Okay.
T. Oh, I like the number 6. That's okay.
Now what's the exponent for 36?
1.
1.
36 over 3.
36 to the third. Yep.
Oh wait, it is.
Yep. And this t is going to be to the first power.
So 36 to the third. I mean T to the third.
T to the 3rd.
Okay, so
Oh, I have a question.
yes.
Can't you, like, divide the 6 and the 3 on the T?
6 to the third.
Okay, so the t's are the same term, right? They're like bases. So what do I do with exponents if I'm dividing like bases?
You subtract them.
You subtract them. So so if I subtract 6 and 3, I get 3, right? Is that going to go in the numerator or denominator?
The numerator.
Numerator. Always, when you do a subtraction, always at first goes in the numerator. What's 9 to the third?
27.
I don't know.
9 times 9.
9 times 9 is
81.
81 times 9 again.
That's like 100.
It's 729.
729, good.
That's a big number.
Okay. Now 36 cubed
Big number.
it's atrocious. It's 46656.
That's a big number.
But now that t to the third disappeared, right? So anything on the bottom here would be this 36 to the third. I'm going to leave it like this just because these numbers are nasty, but you could divide those at least both divide by 3. Okay. But I'm going to just leave it alone right now. Okay. Let's go to the next one.
Oh, that one works hard.
Okay. What's the exponent for the 2 right now?
1.
1. What's the exponent for the 5?
1.
1. So what am I going to do with this negative 2 here and all the exponents that are there?
Multiply.
Multiply. So everything stays put initially. So this 2 is going to stay at 2, but it becomes raised to the what?
Negative second.
Negative second. The x is going to stay there, but it's going to be to the
4.
negative fourth. The 5 is going to stay there, but it's going to be
Negative second.
negative second. And x is going to be
Negative 6.
negative 6. Does that kind of make sense to everybody?
Yeah.
Okay. So now, these two things are unlike bases, right? 2 and 5 are different bases. So we can't do anything with those. They're going to stay what they are. But are these like bases?
Yes.
Okay, so let's subtract them. And it's always numerator minus denominator. What's that give me?
2.
2. So my exponent's going to be 2 for x. Does that make sense? Now, where does that go?
Top.
Always goes in the top. When you do the subtraction, it always goes in the top.
What if it's a negative number and it goes to the bottom?
If it would give me a negative 2, I would still put it up top, but then the next step I would change it. I would put it in the bottom in the next step. Does that make sense? So initially, I'm going to put it up top. All right. So I took care of this stuff in green. And what I really would have here would be this. Does that make sense? Now, do I like negative exponents?
No.
So where's that 2 going to go?
Bottom.
It's going to go to the bottom and become 2 squared, right?
A 5 is going to go at top.
5 is going to go up top, and the x squared is going to stay put, right?
Ooh, this is a
So I get 25x squared over 4.
4.
Wait, which one? Oh.
Because 5 squared is 25, right? Now, there are some other things you can do with this. I like to deal with negative exponents last. This is my suggestion to you. This you have to do first. You have to do power raised to a power first. Okay? So you have to take that negative 2 and start distributing it, right? Does that make sense? That has to be done first. The second thing I always do is subtract exponents of like bases. Okay? I always do that second. Third, then, I adjust if negative exponents exist. Okay, that's kind of with the three things that we're working on right now together. Those are the order that I do things. Steps 2 and 3, though, that order, they're independent. They can be flip-flopped. Okay. If I did flip-flop these, let's flip-flop them real quick. Let's do power to a power. So give me 2 to the negative 2, x to the negative 4, over 5 to the negative 2, x to the negative 6. If I adjust for negative exponents first, where's the 2 to the negative 2 going to go?
Bottom. Wait, yeah, bottom.
Bottom, right? It's negative right now, so it's got to go to the bottom. Where's x to the negative 4th going to go?
Bottom.
The bottom. Where's 5 to the negative 2 going to go?
Top.
Top. Where's x to the negative 6 going to go? Top. So now the 5 squared and the 2 squared, those turn into my 25 and my 4, right? What do I get when I do x to the 6th over x to the 4th?
X to the second.
Yeah, I subtract 6 and 4, right? Or if I wrote x times x times x times x times x times x divided by x times x times x times x, we'll see that 4 of them cancel. We need just 2 x's be multiplied together, right? So we need x squared up top. So hopefully that demonstration shows you that you can do either one of these steps in any order. Take a minute and we'll do this middle one. Do this middle one here on the bottom. I guess it's the last one on the bottom. See what you guys come up with on that one. What the first step is when you raise it a power to a power. So it should be 2 cubed, a to the negative 9th, b to the 6th, c to the 3rd, right? Bottom should be a to the negative 15th, b to the 3rd, x to the negative 3rd. Is everybody okay with that? That's initially the first thing that you should have. Then what you're going to want to go through is start looking at either changing the negative exponents to positive exponents or dividing like bases. Okay, you can do either one of those steps first. When I do it, I'm going to look at those two things and I'm going to divide those. I'm going to look at these two things and I'm going to divide those because those are the ones that are like bases here, right? Okay. And then move on from there. So I'll give you a couple more minutes to kind of finish that one up. All right, so now so what's 2 to the 3rd? 8. So I'll rewrite that as 8. But now, when I look at the green ones, it's going to be negative 9 minus negative 15, right? What's that turn out to give me? 6. And so that's going to be a to the 6th, right? That right there is the reason why I do division first instead of changing negatives, okay? Because sometimes the subtraction will automatically get rid of negative exponents for me. Does that make sense? So I like to do that first. B to the 6th over b to the 3rd, what's that going to turn into? B to the 3rd. And then I've got c to the 3rd, right? All over, so those went away when I did that division, right? X to the negative 3rd shows up on the bottom now, right?
Yeah.
So when I'm done, this thing should look like 8a to the 6th, b to the 3rd, c to the 3rd, x to the 3rd. Does that make sense? Okay. Now here's the thing. In regards to problems that we do, guys, through the rest of this course, we're not going to ever incorporate anything that difficult inside an equation or anything like that. But what it's trying to do, the argument is, if you can do problems like that, you can justify and realize your exponents and problems like this, you should be able to address and work with the exponents of any problem that we do beyond this, because they're all going to be, in regards to the exponents, easier than what these are. Does that make sense? Okay. So that's the division. The plan for the rest of the week is to cover what we call exponential relationships tomorrow. So I actually, now I know this is going to maybe upset some of us, but it's going to be a little graphical. Okay. But we'll talk about how an exponential relationship, what it looks like, how we determine it, that kind of thing, and compare it to linear relationships through tomorrow and the end of the week. Okay.
Yeah.
Did I mention test on Friday?
No.